gravity pull, because of high pressure, nuclear fusion starts, it begins, and the hydrogen nuclei, they fuse together to make larger nuclei. Okay, so let me tell you again that any star like our sun or any other star which is more larger than our star, how it is formed. At the beginning it is just a dust, a collection of dust and gas particles. This is known as nebulae. Okay, so these particles, they are pulled together. Okay, they are pulled together by the gravitation force. Okay, and these particles, they fuse together. Okay, so this initial stage is known as initial stage of a star is known as nebulae or a stellar nebulae. Okay, right. So when they fuse together, there is very high pressure, there is high temperature. So what happens is nuclear fission kickstarts, the reaction begins, the hydrogen nuclei, they fuse together and they form uh, helium nuclei. See, hydrogen nuclei, they are lighter, so these lighter nuclei, they fuse together to form heavier helium nuclei. Okay, so this is how a star is born. Okay, so our next topic is about the life of a star. So we just discussed how a star is being born. Okay, and then now we'll discuss about the rest of the stages of a star. Okay, so initially we're going to deal with uh, the stages of a star, the star just like our sun. Okay, so then we'll also discuss about uh, the other stars, about their stages. For example, stars which are larger than massive stars, larger than our sun. Okay, we'll discuss all those things as well. Okay, so what happens here is initially, you know, when the gravitational forces are pulling particles together, as you know, because of the high pressure nuclear fission, it begins. Okay, and because of the high temperatures, the gases even expand. Okay, so now here what you need to understand here is there are two forces here. One is the compressive force, which is due to the gravitational force. The other one is the expansive force, because of the high temperatures. Okay, and that is due to the nuclear fusion reaction. Okay, so always remember there are two forces here. One is the gravitational force and the other one is the nuclear fission force. Okay, when these two forces are balanced, the star is said to be in a stable period. Okay, so these two forces, they have to be in balance. Okay, see, suppose for example, if the gravitational force is too high, what will happen is the star will contract. It will become smaller and smaller and smaller. Okay, at the same time, if the nuclear fission reaction is too high, the star will expand to a larger level. It will keep on expanding. Okay, so either of these, if they happen, then we will not say that this star is in a stable period. Okay, we will not say that this star is in a stable period. And after that, that is after uh, this paragraph, the other paragraph says that the star in this main stable period is referred to as a main sequence star. Okay, so the words which I have highlighted here, which are in the other colors, they are very, very important words. They are key words you have to note down and remember always. Okay, so this period, that is this stable period, or this star will be a main sequence star for many millions of years. Okay, so at this moment our own star, that is our sun, is in this stable period. That is, our sun is a main sequence star and it is in a main stable period. Okay, so on next slide, okay, it's about the next stage. So what happens is, towards the end of this stable period, what happens is all the hydrogen nuclei, they get over. Okay, it's just like fuel. Hydrogen nuclei, they get over, and eventually the hydrogen fusion reaction stops. Next, what happens here is a fusion reaction takes place between helium nuclei. Before, the fusion reaction was in between the hydrogen nuclei, but now it's between the helium nuclei. So now the story will be different. Okay, again, the energy which is released due to this reaction, nuclear reaction, it allows the star to expand many more times, becomes cooler, and it becomes red giant. Okay, it becomes red giant. Okay, so of course this is not in a stable period anymore, because now you see the forces are not balanced enough, so that is why the star expands. Okay, so this means that the star is reaching its end, okay, its final end, and it will run out of fuel and it will die out. So moving to the next slide, it speaks about the end life of a star, similar to the sun. Okay, so what happens is, when the fusion ends, that is, the fusion takes place between all the helium nuclei, and when the helium nuclei, when they get over, there are no more helium nuclei. What happens is, the fusion reaction ends and the outer layers are pushed away. They're pushed away, there are no outer layers as such. Okay, what remains is just a small core of the star. Okay, that finally it becomes a white dwarf. Okay, so it becomes white dwarf at the end. Okay, then later it's there in the textbook that this white dwarf, again it becomes a black dwarf finally at the end. Okay, so you have to remember this, that a star like our sun, it later, when all the fusion reaction it gets over, when the fusion reaction gets stops, finally it becomes a white dwarf. Okay, right. Now how about the stars which are larger than our star? Now their story is different. These super giants, red super giants, these stars, they explode in the space, and this is known as the supernova. Okay, this explosion is known as a supernova. Okay, and then the remaining core of the star, it contracts and it forms a neutron star. Okay, so this larger one, it forms a neutron star at the end. So you need to remember that the end life, that is, at the end, a star like our sun, it becomes, what does it become? Yeah, it becomes a white dwarf, and it may become a black dwarf as well. Okay, then a star which is larger than our sun in size, it finally at the end it becomes a neutron star. Okay, whereas if a star is a massive star, larger than any other star, then the story is different. This super nova, it happens, then what comes out from the supernova is a black hole. Okay, so finally it becomes a black hole. Okay, so there are three different results, right? And it is based upon the size of the star. So if it is sun, then at the end becomes a white dwarf. If the star is larger than the sun, then becomes a neutron star. If it's a massive star, that's the biggest. If it's the huge star, then it becomes a black hole. Okay, just remember all these, inshallah. Okay, So just make a note of this black hole. This black hole is is not a star, but something which is present in this space. It has a very high gravitational field inside it. Okay, so even light cannot escape. It absorbs the light as well. It pulls in the light. Okay, along with the particles, it can even pull the light inside it. Okay, so this is a very important topic. You might get questions on this in your exam, so remember this much. Okay, so but all these things are just theories. Just have to remember, like how you remember stories and tales. Most of all these things have not been proven yet. Okay, so these are theories. That's it. And the last final one, it's about the brightness of a star, and it's that is the relationship between the brightness of a star and its surface temperature. Few scientists, they discovered this, that the brightness of the star gives us you know some information about the surface temperature. They drew a diagram like this. Inside the diagram you can see there are various sections: white dwarf, main sequence, giants, supergiants. These are sections. Okay, different sections, and they have put all these stars in different sections. They have put all these stars in different sections, and they said that the stars positions in the diagram tells us the internal structure, and also most importantly in what stage it is in. That is, it tells the age of the star as well. For example, Sirius lies in the main sequence just like our sun, so that means it is a stable star, and the next stage of its life will be a red giant. That is, later, after millions of years, it will become a red giant. And another example is Rachel, which is here, over here, which is there in the supergiants category. What this means, how do we interpret this, is that supergiant is already passed through the main sequence part of its life. That is, it's no more star like our sun, and now it has become older. Okay, and majority of the fusion reactions taking place are between the helium nuclei, not the hydrogen nuclei. So it will eventually become a neutron star or a black hole later or sooner. Okay, so this diagram tells us the brightness of the star, and also the age of the star, uh, how young it is. Okay, and what will it will become later. Okay, so this is also a very important topic we need to remember. Okay, so we need to practice makes you perfect. Okay, so I think I can finish this class now. If you have any doubt, you can ask me.